Hello everyone, welcome to ET Manufacturing, and today we are going to discuss something very important, aerospace and defense industry. These two industry has been continuously growing in India and creating huge opportunities for the MSMEs, technology providers, and also creating huge amount of jobs, engineering jobs that will enhance our engineering prowess. Backed by governments push towards self-reliance, a lot of FDIs coming into India, and also many Indian businesses and conglomerates are stepping up to grab the most of this growing opportunity in the Indian aerospace and defense industry. Welcome everyone. We are going to discuss about all these in our 30 minutes of conversation. Welcome to Aerodef Manufacturing Dialogue. And today we have with us Mr. Karthik Krishnamurthy, who is the Chief Operating Officer at Mahindra Aerospace. Welcome, Mr. Karthik.
Thank you, Nishant, and good morning, everyone. Honor to be here.
Thank you. So, Mr. Karthik, to set the tone, I would just like to know what's trending in the Indian aerospace and defense industry. What kind of opportunities do you see for the overall Indian manufacturing community in the aerospace and defense industry?
Thanks, Nishant. I think it's a very wide question, so I'll try to keep it at topic level. I was recently looking at some of the statistics, and I was talking to a few of the OEMs, global aerospace OEMs. And in the last 5 years, there has been something like a 3x growth in sourcing out of India for the world. To put that into context, it's the post-COVID time when the whole industry has still been not fully recovered from all the pandemic supply chain issues, but India sourcing increased. I think that itself is a fantastic testament to how Indian companies or the Indian environment ecosystem is able to spool up, ramp up, and deliver. That's one top line statement. The second top line statement is the more you talk to all the OEMs, you realize that they know India almost as well as we do. Of course, that's a
Yeah.
bit of an exaggeration, but they have realized, they have seen the potential. They tell us about engineering companies that they are talking to. We, of course, are a manufacturing company. They tell us about new innovations coming out of different parts of India, which, of course, we are aware of, but they are sometimes more aware. This means, again, the whole ecosystem globally is aware that in India there is this treasure chest waiting to be tapped. And I think that's a fantastic setting or a base for us to look at the next 5 years and see what magic as a country we can achieve.
Right. So you are quite optimistic about the growth of these two industry. That what I understood from your comment.
100%. 100%.
So, as we all know that, government is continuously pushing towards self-reliance, and we have achieved a lot in defense production. If I'm not wrong, 70% we are making domestically, and only 30% we are importing. And so, still to fill that 30% gap, what are the biggest gap do you think are there to achieve the true indigenization, according to you?
So it's a little difficult question for me to answer. I think when you talk about defense sourcing, it includes all types of defense sourcing, which includes the electronics, the airframe, the aircraft, of course. But I do not know if land systems and naval systems also come into that statistic. In general, if I try to look at it from a outside perspective, I think what happened recently with Operation Sindoor was a eye opener for many people outside India. That lots of indigenous systems were able to prove themselves and come up with shining colors. I think that was a huge statement, under-realized but huge statement globally. The second thing is to answer your direct question: what do we need to do to make it more? I still feel there's a challenge in terms of bringing product to market on time. In spite of all the great technological capability, there are some core technologies perhaps which are where the outside world is far more advanced, and due to defense protocols and IP protection, we have to home grow it. And so I think those kinds of targets, technological targets, I'm not the expert, but I see them as being the biggest stumbling blocks to making the last 30% disappear. Because as we all know, in any technical world, the last 10% is the most difficult. The last 10%, the joke is that the last 10% takes 90% of the time. And
Yeah,
that's where I see the steepening challenge for all of us.
right. So, when these industries grow, like, when they large player from outside start manufacturing in India, they
Yeah.
also form some sort of joint venture with companies like yours as well. We have seen so many examples.
Hmm.
What kind of opportunities it creates for the MSMEs first? And do you think the MSMEs in India that forms backbone for any economy for that matter are
Hmm.
ready to supply the kind of parts aerospace industry needs? Because there we need like a highly precision parts. Do you think the readiness of MSME is intact as per the demand?
Oh, yes. I think the MSMEs are ready and willing and raring at the bit, to use a horse racing phrase. If
Right,
if I can expand on that, back in 2006, we're now going back 20 years, when the defense offset policy was announced, the majorly changed defense offset policy was announced. I think that period, 2006 to maybe 2010, was innocent optimism. The
right,
MSMEs, large companies, the whole Indian ecosystem felt, now we can do aerospace and defense. Then I think there was a whole period of sometimes hard, harsh learning where we collectively realized that this was a tough learning curve, that there were too many new expectations and not all people can meet them. So we have
right,
gone through all that. And I think in the last 8 to 10 years, we have been able to successfully prove as a whole ecosystem that we can do it. In our own example, we have seen some of the people we started developing as tooling suppliers, they have now become independent aerospace buds. And we are happy to source flying product from them as the time goes by. And so we have
okay.
seen some of the young companies that we started to develop. We have seen them develop their wings and now fly along with us. So I don't think there's any dearth of capability interest. I think it's fantastic.
Right. Right. Sir, I think 5 minutes back you also mentioned that, some of the technologies and, time to market is still not there in India. So, how can OEM, tier one, government and startup ecosystem or MSMEs can collaborate and create an environment of innovations and, new IPs, designs kind of thing, so that we can also bridge a little bit more on indigenization part. Do
Uh,
you think the hand-holding is required from the OEMs for tier ones and MSMEs to learn?
no, I think hand holding from any OEM in specific or a couple of OEMs together is, I'm not saying it in a negative way, but then the MSME gets aligned to a specific thought process or a
Right,
certain product family. For
right,
true innovation and independent growth, the MSME should be able to be independent of OEM and brand. If you can understand that, you really need to have a capability that's wide. And for that, I think the two key phrases that come to mind, and this may not be very popular. One is innovation is important, critical, but time to market is one important parameter. It cannot be basic research only. It has to be basic research coupled with an applied research focus, which says, I want to go to market by so and so date. So that coupling or that differentiation between what is basic research, exploratory, and applied research, where you're applying your mind to take it to market. That's
right,
one statement. The second statement, I think, is probably the most harsh truth I have learned along the way. Technology for technology's sake is not good.
okay,
Technology for technology's sake is where some mission objectives start getting compromised because the technology can be even better. And there has to be a concept, an engineering concept of saying, for phase one, this is what we will achieve. For phase two, we can develop it further. So it's a little difficult for all of us, I think, from a technology development point of view to understand the shift here. And there are lots of case studies outside India. This is not something unique or new to us. I think there's lots of case studies in the US and European scientific establishment on the differentiation between basic and market focused research.
and when talking about technology, let's talk a little bit more on the skill development or skilled manpower in India. Do you
Mhm.
think that industry academia partnership will work? Second, do you think there are enough institutes that are teaching specific to aerospace industry? Or if they are not, do you think we need that in India so that we can, have so many aerospace engineers?
So, Nishant, you probably know that this is one of my passion topics. And over the years, I think the way I see it is let's take it as the aerospace industry and classify it into four boxes in terms of the skill set, people skills. There is design and analysis. That's the
Right.
developmental side. That's technology development, technology implementation, new product development, product improvement. That's one bucket, a big, huge bucket called a box called design and analysis engineering. Then there's a second called production. This is hardcore production activity, which is the same product out of the door on time, on quality, every time, ramping up, increasing in complexity. That's one big second box. The third box and the fourth box. The third box is all about program management. It's about planning, scheduling the material, the people, the equipment, the capacity to be able to grow. It's always forward looking, there's always uncertainty, there's a certain maturity in knowing how to manage the risk of planning, that there will be changes in the last moment, knowing how to build this into an 18-month, 36-month, 3-year plan, which is forward looking. So that's a whole
Right.
activity of planning, and it's kind of a developmental activity, but in a totally different direction. And the fourth box, I think, is probably the least well understood, which is the material engineering aspect of it. Let me go from top to bottom. On the first one, design analysis engineering, I think India has got a fantastic talent pool with more people coming into it every year. Uh,
Okay.
when back in my time, the five IITs, I think, and MIT Crompet in Chennai were probably the only places offering aerospace engineering as an undergraduate degree. Today, there's no relevance to that statement anymore. We have enough design analysis capability coming up, and the OEMs and the Indian environment are happily able to resource their programs without any challenges, I believe. In the
Yeah.
second category for production, the government has taken some very forward looking steps already. All of the Bangalore, at least ecosystem aerospace players, have contributed towards curriculum development, testing standards, and we now have an increasing pool of people to work on the shop floor. We have a lot of people coming with adequate skills, and we are able to develop skills further in-house with
Right.
on-site training centers like we have. So the second box and the first box, I would say, are green. The third box and the fourth box, not quite. In the third box, let's look at it in a bit more depth. The universities produce engineers who are excellent at design and analysis. But what you need for the third box is industrial engineering, program management engineering, planning and scheduling experts, which is all kind of various flavors of industrial engineering, but with an aerospace focus. To put that into context, uh, the one of our plants in the Mahindra group, which is not a car company, but they produce small trucks. For them, 400 out the door in a day is not at all a surprise. It's not
Right.
fantastic. It's not a stretch target. All of us know that 400 in a decade in aerospace is more appropriate. So you're talking about industrial engineering tuned to a very high mix, very low volume, high
Okay.
precision, and long lead times. It's a it's a different pool of skills, and we suffer. We struggle to get people who are good at that. So we end up home growing, and it's a long, slow process. And the universities, I think, would benefit from partnering with industries to have some developmental stream saying this is aerospace engineering with a focus on manufacturing. And
Right.
that's on the third box. On the fourth box, especially in the recent times, on one side we have the pressure to have independence on material supply, and we need to develop internal to India material and hardware and suppliers, manufacturers within India. But for those suppliers and manufacturers to become global, they have to partner with the OEMs because they have to be OEM qualified. And that's a slow process. And until that slow process matures, we are dependent on continued imports. So I think
Right.
that's another area where there's a huge potential. It's untapped to bring the skill sets to say, you know what, we can prove that we are as good as you expect. We can fast track the approval process. We can start supplying to the world on the material side. And I don't think that's been fully explored yet.
Right. 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 So there has been a good progress, but a lot of things still needs to be done.
Yeah.
So you spoke about material as well, and as we know that when it comes to making some of the critical part, we are dependent on imports. For example, if we have to do micron level machining, we need 5 axes, and most of the 5 axes are like imported in India. And
Yeah.
then some of the aerospace grade materials are also not, available in India. Of course, in recent years, there are some mills who have got a certification, but still a lot of, these materials are being imported in India. And with the BIS and all these things coming in play, I think it becomes tough for those companies also to get it.
Yeah.
Whereas OEMs have a clear instruction that we want to get material from this particular company only.
Yes.
How do you see this situation, and what would be your suggestion to government, especially in terms of import of these two critical aspects? And it attracts a lot of duties as well, right? So without
Yes.
these 5 axes and material, we can't do anything, but we have to do it, and it attracts duties, and that makes our maybe overall production maybe costlier or something. How do you
Correct.
see that? Yeah.
So again, it's a two-part answer, right? So on the equipment side, yes, the expectation is that if you need a good five-axis CNC machine for aerospace or defense, it will come from outside India. But I can see the progress becoming more and more visible on being able to do that within India. I've heard of companies with expertise from outside willing to set up shop in India to make five-axis machines for India, for example. And we are, in our own case, we are being sourcing the three-axis machines from some of our local suppliers and are looking at them maturing their five-axis capability to a point where we can go local even for that equipment. I don't think the problem there is capability. I think it will happen. It's just a question of the industry taking the necessary learning curve and maturing to the level of accuracy needed on the five-axis machine. That's Karthik's experience, and I'm very, very optimistic that will happen sooner rather than later. That we will have domestic supply of high quality equipment for these kinds of work. I think on the material side, like I mentioned earlier, the challenges are much more wide. So if you go back, there are basic standards for steel. Let's take steel as an example. There are basic chemical compositions and grades and certifications. And the Indian mills already meet all those requirements and produce to that requirement. The problem is the what we need in the aerospace world has two extra requirements: tighter control on thickness, quality, chemical properties, which is it's a finer line of allowables.
Yeah.
Much more challenging is the volume. Not only do we need it to be tighter, we also need less of it. So it's a huge commitment on the mill that for the commercial or the other market, there will be a huge volume of X quality, and then next to it will be a small volume of 2X or X squared quality. So it's a business case challenge. I'm sorry, I'm getting
Right.
an echo.
Yeah. Yeah. Okay.
Yes. So it's a quality and quantity dilemma which will challenge the
Yeah.
business case, I'm assuming, for the local mills. The other
Right.
part
Right.
of it is when the OEMs are instructing that you can only buy these approved suppliers, it's simply because they have gone through both the process and the product and qualified those mills. So it's a process qualification and the product qualification. The OEMs have satisfied themselves that those mills can sustain and maintain that requirement. And that's why you have globally a very few number of mills who are now looking
Right.
at meeting that restricted space of aerospace requirements. What
Right.
does that translate to? It means that our recommendation already presented to the policy and decision makers for consideration has been the same. We need a some kind of a transition period. We cannot go overnight from no more import, no more import. We need to have a transition plan and a transition
Right.
period where the OEMs, the domestic supply or manufacturers of mill material, for example, of material or hardware, the OEMs, those manufacturers, the policymakers, and the users have all signed up to a timeline saying, over this period of time, we will transition from 100% import to 50% import to 0% import.
Right.
It takes a very big coordinated effort to do that, and that has been
Yeah.
our recommendation to the policymakers as well.
Yeah. A more of a sustainable approach towards Indianization.
Yeah, in fact, one additional point that I think which critical point that you mentioned, which I didn't address, in the case of an MSME, they have already extended their own businesses to be able to get into the aerospace world. Putting a delay or a challenge in importing material at the same time not having an alternate is extremely challenging. We will see some MSMEs exit rather than enter this industry as a consequence. And so
Okay.
this needs to be a very holistic plan, roadmap.
Right. Just a couple of more questions from my side. While we are talking about the policy, uh, we know that there has been a good offset policy for the defense, procurement, but we still don't see that much in the commercial aircraft procurement. And when we see India as a market for commercial aircraft, it's about 12 to 13%, I guess, roughly. But in our role in the supply chain is, I think, just 1%. So even if we can get from 1% to 6%, it would be huge opportunities for the Indian overall manufacturing community, aerospace community, right? So do you think the government should also come up with offset policy for the commercial aircraft?
This question has been debated, I think, for a very long time. In fact, since 2006, in some form or the other. When we entered the business, we took a very conscious call that we were not going to enter the business because of an offset policy, but we were going to enter the business because of a belief that we can compete with the globe and succeed.
Right,
The reason I'm giving this background is there are two ways to do something. One is because you are protected and can play in a protected space, and the other is you develop and be as good as the best.
okay,
And you can see the direction my answer is going.
right,
Yes, there is a lot of buying in India from outside of the finished product, whether it's aerospace or defense.
right,
Yes, there is an equation that because we are such a big market, we also should be a good part of the supply chain. But I think for sustainable long-term stability and a robust supply chain in India, that cannot be on the back of protectionism. That has to be on the basis of global competitiveness. Otherwise, some program will end and that OEM will go away from India and the work will go away with it. Versus if we are integral to the global supply chain, we become more policy and geopolitics independent. We prove our value, we keep our value.
right. Just last question, I would say, what does the future look like for you in Indian aerospace and defense manufacturing in India, say in like next 10 years? How do you see this when we talk about the manufacturing per se?
I know that this question comes up a lot. My view is very simple. How hungry are we? How hungry are we as a nation or as a collection of ecosystem partners? How hungry are we to push forward and say that we can do what anybody else can do? And I think it has to be answered very carefully. There is a development side to this, and there is a capability side to this. If you look around the globe, there is a reason why there are only four OEMs really talked about in the civil aerospace domain. Two are huge, Europe and US, and two are, of course, catching up with a very successful plan so far. One is Brazil and one is in China. The point I'm trying to make is development is a long term play and a hugely challenging, cash intensive, high risk path to follow. I don't think we as a ecosystem are looked enough at the alternative, becoming integral to the supply chain on the design side and on the manufacturing side. Lots of countries have done that. They have not, or they are, of course, ambitious in terms of the development side, but they have very clear plans on how to grow the supply side. That we become the world supplier of great, best engineering capability and best manufacturing capability. There's no reason why that cannot be a parallel objective. So over the next 10 years, I would like to see at least both of these having matured to a point where we are really the world's most populous nation and it's visible in both aerospace and defense global markets.
Nice. Thank you. Thank you so much for sharing all the information. And it was lovely talking to you. Great learning for me as well. Thank you so much, everyone, for watching this. Stay tuned for more episodes on Aerodive Manufacturing Dialogue. Thank you.